Hey, welcome to Beyond the Forecast. How's it going, Don? How's it going, Brian?
Yay, good.
We're doing well. It's
doing
been
well.
cooler recently, so that's been my favorite thing.
Yes, it has been cooler. It's been nice that it's been cooling down. And again, this is the last time we'll have a big, long hour show. We're going to change it into daily half-hour shows coming up into the week ahead. But we're going to kick off that, going into that, with my favorite types of episodes, Your Questions.
Yay.
Your Questions. And we brought Don in because Don is going to answer everyone. And we can just sit and watch, though, right?
Sit back and relax.
Yeah,
Don, take it away.
No, so the fun thing about these questions is some of them are related to astronomy, some of them are related to meteorology, and they can get really really advanced. And that's where we're going to start with Michael Knopper's question. I really like this one. What influences how steering winds change in regards to summer storms? It seems that slower winds aloft allow for greater rainfall rates and slower storms.
That's an easy one that any of us could ask, really, in terms
Yeah.
of...
Yeah.
So,
Totally.
and it's a good observation, yes. Upper level winds are real slow. It can be real sluggish this time of year. In the spring, especially, winds are much, much faster in the upper atmosphere. And so things just zip right along. So if you get heavy rain, it moves over the top of you and it's gone. However, this time of year, there's nothing out there just driving anything. It just can meander about. A thunderstorm can meander about.
Over one area.
Yeah, over one area and just dump heavy rain.
And would that be related to, so in the summertime, we still get wind shear in the atmosphere. We can still
Totally.
get severe storms. How would that, maybe the question might be going to, how does wind shear change the rainfall rate? Is that something that's correlated?
I think the rainfall rate's really going to be depending also how much moisture you just have to rain out. So
Right.
not so much as it, shear in the upper levels, but it's the time of the year. How saturated is your column of air? How much rain are you able to get out of that cloud?
Precipitable water.
But it's exactly.
Right.
But it's also something interesting because the steering winds can, like Don said, dictate how fast a storm moves through an area. If there's not much shear aloft, your storm's just going to be sitting over one area for a long period of time, dropping heavy rainfall, and you may look outside to maybe some more localized flooding, and you may think, oh, must be heavier rainfall rates in that case because there's not as much shear aloft. But actually, it's more so with how much water you just have up in the clouds.
So steering winds, correct me if I'm wrong, because I'm just going to throw this out there. 700 millibars to maybe, 300 millibars for steering a storm? Or do you think it's lower than that, just 700 to 500 millibars?
I tend to think it's 500. I just kind of plug
Yeah.
myself
Right around
in 500.
A lot of the time, you obviously want to look up high into the jet stream for the overall flow.
Yeah,
but
what is 500 millibars? Like 30,000?
About
27?
probably
No, it's a little bit
roughly.
lower than that, actually. That'd be closer to around 300 millibars in
Yeah.
the summertime.
Yeah.
So I would say 500 millibars, I'd be, 20,000 feet, somewhere around
Yeah,
there. Mid-level of the storm.
yeah.
Mid-level of the storm. Here, I have this graphic here. So this is more focused on shear, but before I let the text animate, so the middle, let's see, can I draw on this? I'll add a pause, and then will it let me draw?
Because we can talk about how you
Yes.
can kind of tell if there's shear
You would,
based on the cloud and how it looks.
would you say 500 millibars is right around here? Or would it be a
Yeah,
little bit
that
higher?
sounds right.
Sure.
Yeah, that sounds right.
Yeah, so we obviously have a thunderstorm that has a lot of water in it.
Assuming the thunderstorm's really tall and it can make it all the way
Yeah.
up there.
We're going to go with cumulonimbus, the big ones.
Oh, yeah.
We're not
the
going to go with
midsummer time.
No.
Yeah.
Right. Good point. So that's the steering winds will be part of that whole area. It'll be below that part and it'll be above that part where we can get this thunderstorm to move one direction. But when it comes to wind shear, that's a difference where we have the stronger winds aloft compared to the lower parts of the storm. So the viewer that may not understand the difference between those, that's kind of the difference there. Strong wind shear, upper level winds, a better chance for severe thunderstorms.
You had that graphic ready for this question, didn't you?
That's the only graphic
Yeah.
I got ready for today. So if we
was
need
work-
another
yeah.
one, I'm going to be searching. But we'll find it.
But it's, you can test this for yourself. Go outside, when it's real hot and soupy out and thunderstorms are coming in the afternoon, you can watch the clouds and kind of tell, hey, must be some wind shear out there because the clouds are tilted as they go up. If you see a cumulonimbus cloud that's just really tall and really vertical, those are typically your really slow moving thunderstorms. Not a lot of shear moving that storm around. Those are the storms that are probably dumping rain over one area for a prolonged period of time. Also, thunderstorms, for storms to last, a great distance, to travel a great distance, you need that shear, because what is a thunderstorm? Essentially, it's updrafts and downdrafts. If you have your updraft and your downdraft in the same area, you're going to cut off that lift to the storm.
Right.
The storm's not going to be as healthy. You need to displace that storm a little bit so that your downdraft and your updraft aren't interfering with each other. You
Right.
do that through vertical shear.
Yeah, the thing about it is, too, when you get these storms that are sitting in one area, what it means is they're self-destructive. They will, with the lack of, it cools itself,
Yes.
downdrafts, there's less warm air,
air rising.
buoyant air to lift into the thunderstorm cloud.
We have interesting kind of microclimates around here too, which makes
Yeah,
that
that's
very
true.
interesting, because we can get sea breezes off the rivers, off the bays, and that's fascinating to see when that's on radar.
Yeah, what we'll do sometimes is crank the radar up, the gain up, to look at every little piece of dust or whatever that's coming on, that's being detected by the radar, and you'll see these little lines, especially off the James River, on the south side. They'll kind of float on southwestward off the James River. And you
Yeah.
kinda
Yeah,
go,
yeah.
okay, there could be a line of clouds forming there, because what happens is that you have air rising over land and sinking over the water, and that sets in motion a horizontal tube, basically. And that horizontal tube will oftentimes move inland just a little bit, and that's what a sea breeze is. So,
One of my favorite phenomena in this area is actually on the eastern shore, because they'll get a convergence zone over the eastern shore where the clouds will form right in the middle, but on either side it'll be totally clear.
yeah, and a convergence zone means that air is coming together like this for the eastern shore.
Right.
Sometimes it comes together like this.
Sure.
But it's coming together, and it can't. The air is mass. It's got to go somewhere. It can't go down into the ground.
Yeah, there's ground there.
Yeah.
Yeah.
So it's got to go up. And when it climbs up, there's water in the air, and it turns into.
Condenses, cools, and you can sometimes
Kaboom.
get your storms out of that.
It's a Florida phenomenon.
Florida, it happens daily.
Yes.
In the summertime, it's daily.
Yeah, you look at detailed satellite pictures, and you see these lines coming. One line developing near the Gulf of Mexico, the other one off the Atlantic.
Well, I'll say when I was in Savannah forecasting, that was like, it was almost like a thing where we didn't even have to come into work sometimes, and we were just like, yep, it's going to rain at some point in the day today. We just
Yeah.
kind of know, and it
Yeah.
always would.
It's really cool to see it on the visible satellite, on
So
the GOES
cool.
satellite.
Yeah.
That's
skinny
that's a treat.
bands usually.
Yeah.
Because that skinny band also, you could see it just barely, and then once these storms initiate, boom, it's just clouds everywhere.
Yeah. And they're usually relatively benign, too.
Right.
Usually relatively benign. They don't have a lot of wind with them. They can.
I noticed with this last couple of weeks, really into early July, there was a lot more of a threat for some strong wind gusts because these storms were water loaded.
Yeah.
So there's so much
Yeah.
moisture that all of a sudden this rain just whoosh, it comes down. Rain, cooled air coming down fast. It brings the wind with
Yep.
it. And then you can have a strong wind gust.
Yeah, and usually in that case, it's a strong wind gust where it comes down, but also fans out ahead of the rain.
Yeah.
Too. So you end up with this outflow boundary going on.
Yeah.
That continues, and a new outflow boundary means it's almost like a new sea breeze.
Exactly.
So,
Yeah, that's a lot of
Yeah.
times, especially middle, interior sections of the country where they have those kind of thunderstorm complexes popping up. Sometimes in the National Weather Service discussions, they'll mention colliding outflow boundaries, and essentially that can help to initiate new storms during the course of an afternoon.
and we've had a lot of those in the.
Oh, yeah.
But we've had this cool stretch of weather right now, so we haven't had that many thunderstorms. But prior to that, it was hot, and we'd have these big thunderstorms develop, and outflow boundaries were just like going everywhere.
It was everywhere.
Colliding and making new storms.
And I'd point them out, and I said, watch this one. This is going to hit this one at this angle, so we could have right where they meet at angles, for example, one dropping this way, one moving this way. Say a big one moving this way.
Yeah.
Am I doing it in front of the
There you
camera?
go.
Yeah.
There we go. But where they meet, that's probably where you're going to see a new thunderstorm develop.
The one thing that's
Yeah.
interesting with too is you can we can do a better job now casting and looking where the rain is now and where
yeah.
the outflow boundaries are compared to the high-res models. They have no idea sometimes.
No, because
they're sometimes very bad at handling
Yeah,
outflows.
they can be garbage.
It's really hard.
because it's such a micro
Yes.
situation that they just can't pick up. on
We
it.
don't even have a model really that can pinpoint that small of a detail
it
to the
just
full extent.
Doesn't exist.
Right.
The resolution isn't there, too, for the model
The
as well.
technology is limited even today.
It is still limited. Well, we have a lot more questions here. We spent 10 and a half minutes on that first one. So we got 30 minutes to go. That's fine. That's what it's
Great
all about.
question, though.
Yeah, that was a
Great
great question.
question.
That was a good question, Michael. All right, we're back with more coming up in just a bit. Welcome back to Beyond the Forecast. That was a great first question that we've had so far to start out from Michael about thunderstorms. Sophia Yang is asking, how have you seen forecasting methods and technology change throughout your careers? Any drastic changes? And how do you continue learning? So this has a lot of different parts to this question. Don, you want to start with this one?
Yeah, I guess I better because I'm in my late 80s, so I've seen lots of changes. It used to be when I first started at WAVY, there was no such thing as a computer interface. There was no internet yet to really bring stuff in, to bring data in. We just had a teletype that would print out stuff.
Yeah.
And every day I would go out to the National Weather Service office. Used to be at the airport in Norfolk. And I'd go out there every afternoon and I'd look through DIFAX charts. And
the Wakefield office used to be in Norfolk?
Yeah, it used to be before the new radars came about.
Got it.
Yeah, WSR 80AD.
Yeah.
So you'd have to drive there to get the information.
Yeah. So I'd drive there every afternoon. I'd drive there first and then race my tail into WAVY through traffic, get here with the information in my head, and then just go from there.
DIFAX maps, for those that don't know what they are basically we're talking about large scale surface maps?
Surface maps and upper charts as well.
Upper charts as well.
Upper charts
Okay.
too. And really I can remember the upper charts used to come in a 4-panel. I don't remember what was on each panel, but there'd be a 4-panel showing you, whatever
Sure.
on it. And
I never used those. I don't think I've ever seen those. I think I've seen just the surface DIFAX maps.
yeah.
I've seen a surface DIFAX map in college, but that's only that.
Well,
Yeah.
and the thing about it was too, you'd wait for the latest ones.
Right.
So you'd pull them off of the machine and they were wet, and you'd rip them off and put them on this great big conference room table. And there used to be, it used to be the Weather Service office in Norfolk. It was in the old terminal building, and the new terminal building had already been built, but the old one was still there, which was, I think, built in the early 40s or something. Anyway, there used to be another meteorologist from across town, Joe Folks. He was over at Channel 13, and he and I would sit across the table from each other and toss, kind of throw charts back and forth, and he was doing the same thing.
That's pretty cool.
So, that's
Would there be
what
any
we had.
discussion? Or would it be...
Not too terribly much.
Okay.
Not too terribly
And it was
much.
just, would the Weather Service be involved in that room too sometimes?
No, they were busy. They were
Okay.
busy doing other things.
Right.
And
Interesting.
yeah, there was a meteorologist in charge then. It was Terry Ritter, good man, and he was always he would always point things out for people who had not seen something in our area. In other words, watch for the. He would kind of go, watch for this when this happens here. Sometimes this affects things.
Yeah.
And when I first got here too, he told me that come to think of the ocean as a permanent front.
Yeah.
I
I think you told me that when I first came here too.
Yeah, so think of it as a permanent front. And he gave me he passed along a lot of hurricane knowledge as well. Since I'd moved here from the Midwest and was big, of course, on tornadoes and thunderstorms there, he passed along a lot of tropical information. But the thing about it is too, that was then, and then we started getting computers. We got a computer at WAVY first, but it would ingest only just a little bits of data, not very, very much. Temperature, winds, barometric pressure, etc., that kind of stuff, and just basic surface data.
Yeah.
And eventually we got the internet, so, and then forecast models with that. Forecast models began to improve. I was talking a few weeks back about how there was a model called the NGM.
Yes.
The nested grid model.
Or the no good model, depends on who you ask.
Yeah,
But,
well, it certainly was.
But it was good when you had it.
Yeah, it was. It was. I mean, it was the best when we had it.
Yeah.
And what it was grids. It was laid the entire country out and into the ocean, whatever, as a grid, and
At each point, certain variables.
Yeah, it would happen.
To get your
with all this data flowing in, and remember, how many years ago it was. There wasn't nearly as much data.
Right.
There was some satellite data, but they really didn't have a digital interface to enter that satellite data. To make it meaningful. In data quite yet. It was more of a human override factor. Oh, those are such and such clouds.
Yep.
So you had that, but it was a different time. And and there's somebody asked there. Jim Driscoll asked, despite the incredible advancement in 5-day weather forecasting accuracy over the past 50 years, and why do so many people still diss weather forecasters? We occasionally get it wrong.
Of course.
Yeah.
It's hard to do.
Yeah, you're predicting the future, and my goodness, is there any other field that predicts the future as accurately as we do? But I look back, and in 1980, the 5-day forecast, 5 days out, is as accurate as the 1-day forecast was in 1980. That's how far we've come.
That's incredible.
That is.
Wow.
So we are able to predict, a 5-day forecast, 5 days out, and it used to be really the only first 48 hours is all you could really trust. That's the way it used to be. I can remember that for years. Just the first couple of days, you'd trust the data on that, and then anything further out in time than that, you considered it trends. It's going to cool off. It's going to warm
Average
up.
high kind of stuff too goes into factor that.
So,
How about when when you first came here, we had a radar in Hatteras.
yes.
And then the radar, where was the other radar located at that point? So we have one in Hatteras. Where's the next one located?
It was up at Patuxent River Naval Air Station.
Okay.
And we hardly use that one because stuff doesn't move at us. It was almost due north of here.
Right.
So weather doesn't move in from the north that much.
Because the Wakefield radar wasn't there. Because they didn't have an office there.
Yeah, Wakefield radar wasn't there. The Raleigh-Durham radar wasn't really there either, or at least we didn't have access to it.
Was there one in Richmond?
I don't know. Not that we had access to.
So there's just the radar coverage was a lot more sparse than it is now.
Oh, yeah. And
Okay. I'm trying to map it out in my head.
And it didn't make sense as far as covering major metropolitan areas, too,
Right.
like the Hampton Roads area. So we were kind of on the little bit outer edge of Patuxent River Naval Air Station and the outer edge of Cape Hatteras.
Yeah, definitely.
And there was a National Weather Service office down there, and on the Outer Banks, it's great. But these guys from the National Weather Service down there, they were right on Cape Hatteras, right there. There was a road, and it was just like right at Cape Hatteras. It was stationed there for a good reason, to pick up hurricanes.
Yeah.
Yes.
Tropical
That's why
weather.
it's there.
Because Hatteras
That's why it
sticks
was
so
there.
far out compared to the rest of the coast.
But why, bless your hearts along the Outer Banks. It's great. It's a great place to live. But in the winter, it's really pretty dull. Okay.
Yeah.
And I mean, there aren't tourists there. It isn't as busy. And it was for the Weather Service people, they hated it. And they were so thrilled to see me when I came down and did some reports on them. They were like, "Oh my goodness,
An outsider,
Visitors.
yeah.
somebody
Visitors.
came to see us."
They lived for the beach days, I guess, right?
Yeah, but that radar where it was, that was a big help. Certainly in terms of
The tropics, I'm
yeah,
sure.
the tropics.
Yeah.
And I can remember what we had at the time. It was just a phone hookup. It was a phone
Yeah.
modem hookup. It was before there were computers, but phone modems did exist to be able to
Right.
transfer data.
Direct connection to a
Yeah. And so we'd get that, and it had a fake sweep that went around because everybody wanted to see a sweep, but it was digitally coming in even then, even though it was an analog, it was an analog machine, the radar down there, I guess.
Yeah, the technology for me changing hasn't been as much as yours. Mine's just a little slice towards the end.
Yeah.
Because when I was in college, the NGM model was still, you could still use it, but it wasn't being updated anymore.
Yeah.
GFS was around. We started having higher resolution models being
Yeah.
developed, but we didn't have like
Was the RUC in existence
yes,
then?
we had the RUC.
Okay.
That was the only one.
What is a rapid update cycle?
Rapid update cycle. Yeah. So the RUC was the only one, and that's how I used to, because I started my career in Duluth, Minnesota, and I use that heavily for fog and cloud forecasting. Lake Superior doesn't get much above 60 degrees Fahrenheit. So that created foggy days and just trying to figure out where that fog was going. So that was early in my career, that was kind of a guidance for me. And then eventually we got models like the HRR. We got upgrades to our own weather system. Our weather system has its own model now called the Graph.
Graph.
I don't even know what it stands for.
I don't either. I was
don't
going to ask
either.
you.
Yeah, I don't know what it stands for.
It was.
I know her is the high resolution rapid refresh.
Yeah, and I just called it the HRR.
Yeah.
And then the NAM, the North American model, we have a whole bunch of different
Yeah.
models now. You think your time seeing changes is short. Mine's even shorter.
Yeah.
Mine's
Couple
really
years.
short. I mean, the biggest thing that we've seen change is the introduction to the AI models now in the past, year and a
Yeah.
half, 2
Yeah.
years. That's the only thing that's really changed much for me. Start really going into college and learning a lot about different types of forecast models and then getting into my career. Not much has changed in that regard, except for maybe the introduction of the AI stuff.
And I haven't jumped into them yet. Have you guys jumped into the AI models? that much?
I've looked at the
I know the Euro. The Euro
Yeah.
has one.
and Google has one too. For
Google has one for
hurricanes.
hurricane.
I'll send you that
Yeah.
link again. I and I can probably share it here too because I think
It's really,
public.
it is really cool.
Yeah,
It's really cool to look at.
I've seen it, but I haven't played with it.
Essentially,
Yeah.
the one on on Google that plots the hurricanes. It plots the centers, right? The centers of
But,
load.
but it
Yes.
does it in an ensemble way. It
Yes,
takes
it does.
So there
Yes.
are a bunch of dots.
Yeah, and
And
both
if the
all
dots
the
are close together,
High confidence.
ooh, high confidence.
Yeah.
And sort of like the spaghetti models, if they're all in a line and they all agree all the way through, high confidence. That's where the thing is going. I call the spaghetti models the spaghetti straps,
Oh,
just to be silly.
yeah.
You didn't even know that.
Don's
you
a silly
did.
guy.
No, we haven't gone through a hurricane season yet because Brian just got here.
I just got here, and it's been a slow-ish start, kind of.
Yeah,
somewhat.
Kind of, sort of.
kind of.
Just not a lot of big storms.
Well, E could be next, Aaron.
Yeah, and
We'll be watching.
and,
Yeah.
Potentially
and,
for that
historically, statistically,
August it starts to ramp up.
August 15th, boom.
Boom.
Yeah.
Yeah.
It can just light up like fireworks.
Yeah, from the-
just boom.
The day that we're recording this, that's 9 days from now. So, yeah, that's coming soon. The last part of the question, then we'll do a quick break. How do you continue learning? So for me, it's multiple ways. There's online communities where meteorologists get together and we talk about whatever's going on in the business, but also they'll say, hey, there's a upgrade to the GFS. Check this out. And I'll read through that. I'll get an idea on what's going on with that model, how it's changed, if it's improved, and how it's improved. Another way that I continue learning is when we get new meteorologists that join us here on the
Yeah.
weather team, that's kind of like fresh knowledge.
Yeah, we steal their links too.
Yes, we do.
Because
NVM.
different people will have different links. Ooh, that's a good link. I like that one.
Yeah.
Our good old friend, the NBM,
Yeah.
Yes.
National Blended Models.
Yeah.
Yep.
It's been a helpful tool.
Yeah, NBM Viewer. Yeah, that's one of the last things I look at before.
Oh, really?
Before I put a 7-day forecast together.
Yeah,
I'll look at
it
that.
really
Yeah.
is a helpful tool. Also, AMS conference. I went to it in college. I attended it. Learned
Yep.
a lot from that.
Yeah.
Just like a lot of it, though, now with the internet, you can learn a lot through those forums and those online discussions. For at least for us meteorologists, there's a lot of groups that we've been able to kind of see what everybody else is kind of up to and what everybody else is looking at.
A lot of it too is I forget over time. So I'll forget
Yeah.
some things that I don't use. Like every year we have hurricane season, and this is kind of more simple, but I have to remember how to edit the graphic every year.
Yes.
Yeah.
I mean, there's things that
I
are
had,
like
to, I had to do that. I think it was Sunday night. Sunday night when Dexter went, oh, okay. Oh, gosh, I got to figure this.
Yeah.
I got to put this together. And I did, but it was like, oh, okay.
It's the same thing the other way around with snow, too. I remember at
Yes.
Penn State when I was
Yeah.
forecasting for the campus weather service, we would be all the time in the winter, snow, snow, snow. I moved to Savannah, Georgia, and I don't see snow for 2 years until this past winter where we got a little bit, like around an inch of like sleet, snow. It was like crusty kind of snow. And I was like, I saw it showing up on the model. I knew it was coming, but I saw it showing up and my brain went, oh my gosh, it's snow. It's the S word.
Yeah, I want to plug something here as long as you talked about that. We had a big snow this year, and which is very unusual for us to get a big snow. It's been unusual lately to get snow at all.
Yeah.
And I can remember one of the last places before I started putting stuff out, and the forecast models were kind of going down with the snow, saying no, it's not as much,
Right.
not as much.
Right.
But I looked at the National Weather Service, and the folks out there were still going, nope, it's still going to be big snow. And they were still going higher than the models were.
Yep.
And I went, okay, I'm going to stick with these guys.
I remember that point.
Yeah.
I remember we were like, I think we might need to lower these totals.
Yeah, because they were just so outlandish.
Yeah, 13 inches, 15 inches.
yeah,
What? For Hampton Roads? No way.
Yeah.
Yeah.
And the models were doing that, and I'm going, okay, well, and you had mentioned discussions, and that's where I'm looking at the National Weather Service office locally, Wakefield. They'll put out a discussion, so you'll see what their thinking is, and their thinking might have something different. Oh gosh, I didn't think of that one.
Yeah.
That's why this is happening. Oh gosh, So it's nice. It's like having another couple of meteorologists sometimes.
Yeah.
When there's a tricky situation to look at.
And those guys who don't have to worry about, the upcoming newscast, they are just drilling into the data constantly.
Yes.
Looking at each new run in detail.
Yeah, and I note that 450 employees of the National Weather Service are being hired back. I don't know if you saw that.
I saw that. Yeah, I
So
saw that
that's
earlier today.
huge.
That's great
And
news.
pardon me for giving kudos to the National Weather Service, but they deserve it.
Well,
Oh,
yeah.
100%.
Yeah.
As we roll the break here, I'm just going to pull up the National Weather Wakefield website. If you want to find those discussions, you have to click on the local area. So when you see the map, just click towards Hampton Roads, scroll down, and all the links here, including the forecast discussion, will be down here.
They're really
So-
helpful tools.
Yeah,
they
you can-
really
Yeah.
are.
Yeah, so if
And
you
it's-
really want to geek out, this is the thing to learn. And it can be complicated. I mean, here's the text. You can't read it, but it can be complicated, but there's hyperlinks on these words so you can find out what they mean.
What
You
they
can-
mean,
You can
of
continue to
course.
learn more. So it's a great resource if you really want to geek out and read the latest things that they're thinking.
Yeah, I
Also-
don't use it every day, but on those days, when I'm going
High impact stuff.
high impact days, I
Yeah.
want to have a last look at that.
Yeah.
And real quick on that site, there's also marine forecast stuff, which if you're going out in the water constantly,
Use those.
you need to use those,
Yes.
especially around here. We're surrounded by water.
Yeah, for the boaters too.
Yeah,
Yes.
and we don't have time to do them so much, and plus I cannot be responsible for somebody not taking advice. I just don't feel that I can be responsible by giving a boating forecast and them not heeding it.
Totally.
So-
Right, or not being up to date with something that may have changed for the boating forecast.
Yeah.
Because that's
It
a total
changes
different
all the
world. And
time.
if you're in the
Yeah.
middle of the bay on a boat, that's a
Yeah.
whole different world.
You got
Then overland, for sure.
Coast Guard radio, let everybody know where you are, what your destination is, everything like that, and
Yeah.
and make sure you look at everything before you go.
Yeah, so follow their stuff for the marine stuff. It's great.
Yeah.
All right, we're going to come back with more. Stay tuned. Welcome back to Beyond the Forecast here. Good question coming in from Sherry. What challenges and influences are forecasters face when reporting on weather in the peninsulas?
Well, the peninsulas are a really dynamic area because you're surrounded by water.
Yep.
Number one, we kind of talked about it before. A lot of times you can have these colliding boundaries, these sea breeze or sometimes bay breeze fronts kind of colliding and creating clouds, sometimes creating storms. It's just an area where there's a lot of different air masses that can kind of clash in a micro scale way.
But essentially, it's not horribly different.
I would say Eastern Shore would be a little different.
Yeah,
It's
Eastern Shore is.
it's
the
at
other
a small
peninsula is
scale.
probably not.
I'm sorry?
The rest of the peninsula is probably not
Probably
that different.
That's
not.
I mean more about the Eastern Shore. For
okay.
sure.
Yeah, absolutely.
Okay.
It's in a
Surrounded
micro
by
scale
water.
way.
Yeah, and but even for the peninsulas, the peninsula, middle peninsula, northern neck, yeah, there are some micro scale
Yeah.
kinds of things where there is a sea breeze coming off the York River too, quite often. You know, and you know, so you watch for these little sea breezes in the summertime, and also in terms of snow.
That could be tough.
Yeah, that could be really, really tough because you know, you'll get to Gloucester Courthouse and have 4 or 5 inches of snow. You get to Gloucester Point in Yorktown. Oh no, it's a little bit of a mixture and nothing
Yeah.
sticking.
Yeah,
you know,
'cause you're near the water.
Yeah,
And that didn't happen this winter. All the big snow happened
all
more
the way
south.
to the south. Yeah,
It was total opposite this last winter.
Yeah,
One thing that I have, speaking of Gloucester Courthouse, that's my challenge is I don't have enough data from the Middle Peninsula.
yeah. This is true.
The
Yeah.
Peninsula, I'm okay because I know I have Newport News, I know I have Williamsburg, I know I have Hampton. I pretty much am okay. Yorktown, I can pretty much interpolate what's happening. It's not
Yeah.
that far away from the Newport News Williamsburg airport where that ASOS is. But for the Middle Peninsula, I'm looking at personal weather stations or reports, and I'm like, what? How much rain did they get?
Yes.
If there's a thunderstorm, or how much snow did they get in between Gloucester Courthouse and the Point?
Or has that cold front moved through?
Right.
You know, where's the wind shift line there? Well, there's a dead space in terms of data on the Middle Peninsula. So
Yep. I have more information coming from the Eastern Shore almost in a way, I'd
Yeah.
want to say, than from the Middle Peninsula.
Yeah.
Northern Neck is tough too.
yeah.
So that's my challenge. Is I
Where's
can't verify.
Where is the only? I think there's. Where's the only place in the Middle Peninsula? I think it's farther inland up.
It's Saluda is our only
Yeah,
site.
Saluda is our only. Yeah, that's not.
And that's
inland
not
so much.
that's not really Middle Peninsula, is it? Well,
Yeah, it is. Yeah.
It is, yeah.
Yeah, it's on the Rappahannock River.
Oh,
the
yeah, it's right
southern
on the
side
north, yeah.
of the Rappahannock
That's right.
River. So.
yeah. There's missing data. I'm trying to find that one page where I can see all the sites, but I don't have the link saved right
Yeah.
here.
Yeah, so yeah, there can be you know, to know has everything changed over to snow, solid snow in Gloucester Courthouse yet? You know, or is it a mix? We're looking at the radar, and the radar kind of flops back and forth. It doesn't give you a really solid idea. Yes, the snow ends here, and yes, a mix begins here, and then it's rain, because it flops back and forth between a mix and snow and rain. So you never know for sure if it's been snowing solidly. Radars are great, but that rain snow line is real tough. And
Weather
sometimes
forecasting in general just gets a little bit more tough when you introduce big bodies of water nearby anyway.
yeah,
It does.
Well, plus there isn't as much information coming in, and if weather moves from west to east, you've got a
Yes.
whole continent worth of weather observations. You know how fast that cold front is.
Yes.
You know, you can time it from Chicago to Peoria to Indianapolis and West Virginia and all the way here.
Until late June and July when the fronts die on top of us.
That's true.
Yep.
This is true. But there's a certain period of time, too, in early June, usually, when fronts make it all the way to here and then just stop right in over the top of us.
Yep.
You know, and
And then you have that daily storm chance when they hang around
Yes.
enough for enough time.
And there's going to be a 15-degree temperature difference between the south
gosh,
side
yeah.
and northeast North Carolina and the peninsula and the peninsulas.
Oh,
You know,
sometimes the Eastern Shore. I
Oh,
think
yeah.
you could have temperatures that hang out in the 70s all day. Meanwhile, you just go right over the Chesapeake bay, and it's in the 90s sometimes.
Yes.
Yeah.
It's a crazy difference.
It can be unbelievable.
Yeah.
Water temperatures, air temperatures, that kind of leads into the next question from Charles. In the last few summers, he comments as they felt or seem hotter than the summers past, which some of them have, some of them have not.
Yeah,
we
I
look at the
looked.
records.
I
And then
looked.
bay water temperatures are warmer than normal, which I know this year they have been.
Yes.
They've
They
been-
have
they've
been the
been warm.
past few years.
So global warming or a weather trend?
Well, a weather trend and
In the short term would
weather
be more
trends.
trends.
Yeah, but it's been long enough enough of a trend, so I think we could say climate change.
Climate change on
on
that.
that one.
Yep.
Because it didn't. It used to be that water temperature didn't get, and it used to be the South Island of the Bay Bridge Tunnel. Used to be the the premier station to record the water temperature.
Oh, that was a spot. Okay.
Yeah, and it never got above 80. It would get up above 80 for maybe a couple of weeks or something, and that would be it. And it would never get to 81, and sometimes it wouldn't make it to 80. But every year now, we're seeing it 82, 83 degrees.
Something really interesting too for like the past few summers, the overnight lows too.
Yes.
Have been really
Very warm.
really warm.
Yeah,
And even growing up in New Jersey, I even remember there were some nights where you'd have a nice coolness to the air
Yeah.
at night. You'd be looking forward after a really hot day. Sometimes now you can get stuck in these patterns that it's almost like it seems like they're lasting for so much longer now, where the overnight low just hangs out around 80 degrees.
yeah.
And it's like,
Well,
what in the world is going on here?
And that does fall in line. And I did some graphics on it, and I did a whole big thing. Maybe we'll do it again
Yeah.
here sometime. And that was a question that I had. I said, we haven't seen a record low temperature now for 2 years at the time.
It's maybe been 3 now.
Yeah. And so I went back and looked through and just went through all these charts looking for record lows. And there weren't any. And there just weren't that many.
Yeah.
And so I said, okay, well, I put together what's going on with it, and when there have been more record lows and record highs, and going through the past century or so, and put together some meaningful information, meaningful data. 2010s or 2020s, we can't yet, because we're only 5 years in, or 4.5 years in, so we can't do that quite yet. But we've got it through the 2010s. And one reason, by the way, too, that fits in terms of nighttime lows, why we don't get as cool at night, is because there's more water vapor. There's
Yeah.
more water in the atmosphere.
As you warm the air, you have more. You can hold more water.
Yeah, but then that is true. Otherwise, it's true. Kind of when you turn that around, if there's more water vapor in the air, it's not going to get colder.
Right.
So
You put a lid on essentially
on how low
how
the
much your
temperature
yeah,
can go.
exactly, how your fluctuations can go.
Yeah. So we don't see a huge number of record highs. To really say,
But we
climate
do
change.
see a lot of record high low temperatures,
Yes.
Yes.
essentially.
And
Those
So the
overnight
overnight lows being the warmest that we've ever seen for a particular set of days.
And when
Yeah.
those overnight lows are warmer, that goes back to the water temperature. That warms up the water temperature that we have, because those low temperatures. I found a graphic here. This is looking at the average water temperature for the bay. This is not for the ocean. This is for the Chesapeake Bay, and it peaks on average at 80 degrees Fahrenheit. But we've
It's
been above 80.
It's been like
Yeah.
what,
Since
mid 80s?
early June.
Mid 80s.
Yes.
It's also been, this could also be kind of going into it too. Not a whole lot of energy in the water either. It's been flat. So it's just a lot of times this water very calm. You don't have as much upwelling.
Yep.
This summer, I feel like we haven't had a lot of that. Not a lot of storms to, kind of mix up the water a little bit.
Yep.
And
Yeah.
so we've been able to really warm things. I mean, what was the Virginia Beach has been in the low 80s for quite some time now for the past few weeks, the water temperature.
Really,
and I remember
since
looking.
June.
I remember
Cape
looking.
Henry,
At,
last I checked, it was in upper 70s. It
was
pulled
it now
back- it pulled
pulled back
bit.
down a little bit, maybe
But
with the
I mean,
wind?
we're between 77 and 83.
Yeah, but
is what
and
it's
the
sitting.
Bay has been what 84. I think I remember seeing like an
Yeah.
85 pop, and I was like, "Whoa,
Yeah.
like, that is really warm."
Really warm.
Yeah. And a couple of summers ago, I remember Florida they had some water
Oh yeah, it
temperature
was
readings in
near the
90.
Keys, 90 something
Yeah.
degrees, like a hot tub.
Yeah, I mean it was too hot to enjoy swimming in, certainly.
Oh, yeah.
it was near the Keys, and it was in kind of some swampy areas, but
Probably shallow water, standing.
yeah, but nonetheless, it was killing off coral and sea life because it was just too hot.
One interesting observation, if you haven't noticed on this graph, and it's just like our air temperatures, and this goes into the question from Joe. Joe is saying, do we start getting these occasional cooler days because the Earth is beginning its tilt away from the sun in our hemisphere? So we look at the graph here, this chart, the first day of summer in late June, 21st, 20th, depends on when that solstice is going to be on, for what year it is. But the warmest part lags behind. It takes
there's a
longer for that
temperature
to
lag.
have to warm up.
And that's with air temperature.
Yes.
With water temperature, it takes even longer.
Yes, it does.
Because when you think about it, it's a reflective surface to a large extent.
Yes.
And it's a chaotic surface. There's lots of cold water underneath and warm air and
currents
winds
circulating,
on top,
yeah,
etc. And salinity even affects it. So that it takes even longer for water to warm up, but it takes longer for water to cool down.
Yeah.
So really the peak of the hurricane season is August 15th and really peaks on September 10th. Now,
Right.
that's well past
The peak.
That's
the
almost
peak
fall.
heat.
Yeah.
That's almost fall. Yeah.
And it's because of that, the fact that it takes water that much longer to cool down after being warmed up.
I mean, well, you got the peak sun angle, and then you have the peak temperature, air temperature peaking, and then finally followed by that is the water temperature.
Yeah.
Water is the great moderator, as one of my professors at Penn State would
Yes.
always say, and that's especially prevalent in the fall a lot of times when later in the fall too, when you start to get these big cold fronts moving through, the air temperature is cold, and you go to near the water, it's a little bit warmer.
Yeah.
Any
Little bit warmer.
concerns with this hurricane season coming up with how warm the waters have been, not just here obviously, but in the rest of the ocean?
I mean, naturally, yeah. I feel like naturally
Water's
you're going to
warm.
think about think about it. We haven't, had too many storms to upwell a big air. I remember, what was the storm, the B name storm last year? Was it Beryl? Beryl was the
Yeah,
big
I
one
think
last
so.
year.
Yeah.
I remember in the wake of that storm, there's a lot of
the
water
big
that got upwelled that had to take some time to warm back up again for the next storms. And we really haven't had anything huge to really upwell a lot of water. So there's a lot of warm water to tap into right now. So naturally, I feel like it's going to be a concern.
An interesting one too, and I'd done something on this one too, and it was Milton, I think, was
Milton, the rapid intensification,
one.
Yeah,
the real
that
big
big
one
one.
last year.
Hurricanes, especially if they're slow moving, they create this upwelling of water, this turbulence in the water.
Colder water to the surface.
Yeah, colder water comes up to the surface. Well, that naturally cools that kills off the tropical system, the hurricane or
if it's
tropical
moving
storm.
too slow,
Yeah.
of course, yeah.
And the problem was with Milton, the rapid intensification was it was not bringing up colder water.
Because the Gulf was so warm, so deep.
So deep.
Yeah.
So and that is like
Another
climate change.
of course, yeah. That's
Here's
another
here's
layer
an image
to
of
it.
Milton from the GOES satellite when it was at its or
At
near
its
its strongest
peak.
point.
Wow.
180 mile an hour winds.
Yeah.
was
And that's
its strongest
sustained.
point.
Yeah, but
Sustained.
but I
The
think
crazy thing is that
and
was
I-
sustained.
Yeah, I don't remember how many miles an hour it went up. It was, I think it might have gone from a strong tropical storm to
I think it was 12 hours, right, or something like that.
something like that.
It was
yeah.
crazy.
Yeah, if you look closely, here's you can see Mexico and the Gulf kind of line
yeah,
right here, and
There's
then
the Yucatan
Texas
Peninsula. Yep.
and Yucatan right here, Texas to Louisiana, kind of in this zone here on the northern side of the Gulf of the water. So you can kind of get an idea on where this is positioned.
Thankfully, it encountered some shear,
Yes.
some winds in the upper atmosphere, and started to weaken a bit as it before it made landfall.
Can you imagine if it made landfall on the west coast of Florida at that peak strength?
Yeah.
That was the scare for the hours leading up to it. And it's like, okay, is this thing gonna slow down a little bit?
Yeah. Plus, they'd had Helene.
And weaken a little bit. Yeah,
They
they had
had
Helene. They
Helene.
had flooding earlier.
Yeah, that's right.
I know. Remember, a big topic was Tampa. Is this thing going to be north of Tampa or south of Tampa? That
That's right.
dictates
Yeah.
the surge. They were expecting a 25-foot surge at one point.
Yeah.
And then it, luckily for them, shifted a little bit further to the south. They had the opposite effect where the water
Yeah.
got sucked out of the Tampa Bay, but that left areas to the south more vulnerable. But luckily, like you said, it encountered shear. It weakened at least a little bit before making landfall.
Yeah.
So that's all the time we have for now. Thanks, Don, for joining us.
Oh, sure.
Thanks for spreading that knowledge of what you have, especially with the technology changes. That was fascinating.
Yeah.
That's really cool to see how DieFax maps and stuff like that, passing maps around.
Oh,
That's
man,
cool.
it's like the Model T era.
There's more questions on the sheet here that we didn't get to, so we're going to get to those as we go into the next couple of weeks ahead, and even next couple of days, because starting on Monday, our show will be live at 3 p.m. every weekday. So we're going to have live interaction with you if you have a question on the spot, and we're going to be able to talk about current conditions, because right now we can't talk about a weather forecast just because it's simply...
It airs for the whole week.
Yeah, so we're going to have a live weather discussion here coming up next week. So thanks again for watching, and we'll see you next time.